Hi guys, Harry here. Welcome to Scrap Science. We're going to try taking a step back from the chemistry today, try something a little bit different on this channel. We're going to try making Lichtenberg figures with a high voltage, high power transformer. We don't have much of a reason for doing this, we just think it looks pretty cool, and recently we got a new microwave, so we can use the old one, take the transformer out of that and use that to generate our high voltage in order to zap our pieces of wood. Now before we get started, I just want to make something clear. That is the fact that this is probably the most dangerous thing I've ever done on this channel, or definitely the most dangerous thing we've ever done on the channel, and probably going to be the most dangerous thing we will ever do on this channel. So this is not in any way meant to be a tutorial for you to follow along with, simply because there is absolutely no way I can in this short YouTube video teach everyone how to do this safely. The microwave oven transformer that we're going to be working with in this video outputs around about 2000 volts and has no kind of current limitations, so it will happily just shove a whole amp of current through your body, killing you without even tripping any kind of breaker. So definitely something to be fearful of and treat with a lot of respect when we actually set up to do our Lichtenberg figures. So please, it is very important that you don't actually try any of this at home. And with that said and that understood, we'll go ahead and take the microwave oven transformer out of my old microwave. Alright, here we are inside my old microwave. Once again, this is really something that you should not do if you don't know what you're doing. If you mess up while you're taking apart a microwave, especially with this capacitor down here, you'll actually die, right? It's not like all the other experiments I do on my channel where you just fail in making sulfuric acid, right? If you touch the wrong thing in here while you're taking it apart, you will actually die. But with that being said, I have disconnected all of the wires and stuff that we need to disconnect in order to get that transformer out. I have unscrewed all of the screws we need to unscrew, so I'm pretty sure if we just now get all these wires out of the way, we should be able to get that transformer out. Excellent. That's what we need. Well, that's the only part we actually need out of the microwave, the high voltage, high power transformer. Does it tell us what voltage we get? Doesn't look like it. Just 230 volts, 50 hertz input. Yeah, that's all we need for now. There are a bunch of other cool parts to a microwave as well. We've got a big fan here, that capacitor that I was talking about before, big high voltage diode. There's the magnetron, of course. I don't want to take that apart because this is a really old microwave, and it's obviously using some beryllium oxide, I think, insulators, and I definitely don't want to get beryllium poisoning if I mess up taking that apart, so we'll leave that be. There are some cool magnets in it, but yes, we'll definitely leave that. We also have the power cord that goes to our mains input that I believe should just plug straight in to that. Yes, excellent. So we can just power that straight from 230 volts. So let's get all this stuff, get it up to the bench, and we'll get on to some Lichtenberg figuring. Here we are. We've got the transformer out, got the cord. Basically, it's a very simple device, the transformer. It's got our input here, so this connects up to the primary winding, which you can see down there. This just connects up to our 230 volts, which we plug into the mains there, and the output is simply from the secondary here with some much finer wire. There are a lot more turns in the secondary, allowing for a higher voltage. The output is between this prong here and the actual casing of the transformer. You can see, maybe it's on the other side, the other wire from the secondary just connects to the body of the transformer here. So our 2000 volts will just need to connect to this connection here, and somehow will connect to the body as well. These other two wires which come out the front here I think are like maybe 6 volts, maybe 12 volts, which run the heater element for the magnetron. We're definitely not going to be needing those, so I could probably cut them off, but I don't know, there's no point, we'll just leave them there. And that's that. This is pretty much the only piece of equipment we really need. We'll just plug it in, connect up the 2000 volts to the piece of wood of our choosing that we want to do our Lichtenberg figuring with, and then we'll make up maybe a little bit of a sodium bicarbonate solution just to lightly paint on the surface in order to make the surface conductive for our traces to traverse along. So I'll get that set up and hopefully get it to work. Try again maybe? Just spread it out a little, yeah. Yep. Just need that spread a little bit. So this is the final result. You can see our first one we left running for quite a while and left some pretty deep traces which kind of stained the wood around them. And then we have the second run, which was between that point there and that point there. This one was kind of interesting because we got branches right in the middle between the 2 points. You can see we get some really quite nice detail on some of these like fractal trees that we're getting. It's pretty cool. We also did a few other ones on the other side of this piece of wood. Didn't film it. We started putting a bit of a finish on this little quarter here. We tried making some kind of smaller ones, and you can see we still have that same kind of level of detail with just the tiny little fractal trees, but we basically just put our probes there, did one there, just a whole bunch of little ones. Basically what we found was the distance between the electrodes really doesn't matter all that much. You still get the same kind of shape with the branches and everything, same kind of rate of branch structuring as well. The solution of bicarb soda that you paint on between the electrodes, we kind of just had to trial and error with that. The more concentrated it was seemed to be better, and the less you put on also seemed to be better, but if you put on not enough then it will just evaporate off as soon as you turn the current on, which ruins the connection. The other thing we noticed, we also tested with some other types of wood. The wood with the finest grain seems to work much better than the wood with large grain. You can see over here we've tried with another piece of wood which has some wider grain, and it just doesn't quite come out the same. We get much thicker traces, and they tend to follow the grain quite a bit, but nonetheless we do still get quite a high level of detail with the branches that come off those central points. But basically That's that. It's the final result. I think it looks pretty cool, very detailed and very nice. So that's that. See you later.